Welcome to Lesson 2, Evaluating Algebraic Expressions. So yesterday we learned how to write algebraic expressions, so this one should look familiar to you. But today we're going to be evaluating them. So essentially, when you replace a variable with a number in an algebraic expression, that's when we are evaluating the expression. So over here we have our expression, 2n plus 5. And from what we remember yesterday, this can be read as 5 more than 2 times a number. The number we don't know, therefore n is our variable. Well, if we let n equal 3, the way we evaluate this whole expression is by substituting the 3 into n. So we would write down our 2, and now we're going to be putting in the number 3 instead of n. And we're going to continue with the plus 5. So now in order to solve this, we need to do 2 times 3 because that's what 2n means, 2 times n. So 2 times 3 will give us 6. And since we don't do anything with the 5, we're just going to be carrying it down. And now we solve. 6 plus 5 will give us 11. 11 will be the answer to this expression when n equals 3. So when n equals 3 and we substitute 3 into n, we can see that 2n plus 5 will give us 11. Another way you may see the question on the previous page is by this table. So on one side of the table we have our input, which is just our variable n, and on the other side we have our output, which is the algebraic expression. So for our input, we have here the numbers 1 to 4, so that means n equals 1, n equals 2, n equals 3, and n equals 4. And the purpose of this table is to solve our algebraic expression while putting these numbers, while substituting these numbers in for n with our output. So let's try the first one. So if we let n equal 1, then we can write our output as 2 times 1 plus 5. And in order to solve this, 2 times 1 is 2, plus 5 is 7. For the second one, we have 2. Now we let 2 equal n plus 5. We know that 2 times 2 is 4, plus 5 is 9. And for the third one, we have 2. We substitute the 3 instead of n, plus 5. We know that 2 times 3 is 6, plus 5 is 11. And lastly, we have 2. This time we substitute the 4 in for n, plus 5. We know that 2 times 4 is 8, plus 5 is 13. Later on in the unit, you will see how evaluating algebraic expressions can be really helpful because let's say we want to know the output if we let n be 20. Well, instead of filling in this whole chart, we can just substitute it right away. So we will have our 2, and if we let n equal 20, we can put 20 plus 5. And we know that 2 times 20 is 40, plus 5 is 45. So if we let any number represent n, as long as we put that number into where n fits in our algebraic expression, we can solve it. Lastly, I'd like to clear up some misconceptions that we may have about algebraic expressions. So over here is our algebraic expression. And what you may have noticed is that algebraic expressions do not contain any equal signs. Therefore, we cannot solve them unless we are given our variable. So if our variable is given a number, for example 2, well, we can go ahead and solve it like we've done on the previous page by substituting 2 into n. But if we just have our expression, we cannot solve this or evaluate this because n being our variable can be any number that we want. Lastly, I want to go over 2 more really important concepts. So we have the 4, we have the n, and we have the 6. So as we know, this n over here is called our variable. So we can write n equals our variable. The reason it's our variable is because this number can always change, and it can be any number that we want it to be. Well, is there a term that we call this 6 and this 4 over here? In fact, there is. The number 6 over here, or the plus 6, is called our constant. What this means is throughout the mathematics that we're doing here, although other variables may change, this number will always stay constant or the same. Lastly, we have the 4 attached to our variable over here. Whenever we have a number right beside a variable, we call it the coefficient. So the number 4 is called our coefficient. So the coefficient is the number that is used to multiply a variable. So in this case, the coefficient is 4 because it is used to multiply it to the variable, n. So your ticket in the door for tomorrow is to solve this following expression, 4n minus 2, or it can be read as 2 less than 4 times a number, using the input and output chart. So letting n be 1, letting n be 2, letting n be 3, and letting n be 4. I'd like to see the different outputs, just like we've done in the previous slide, for the following expression. So please copy this table into your notebooks, and we will take this up tomorrow. Good luck!